Okay, I don't want to lie, so I'm not going to. Most of school is not about the information that you retain. Because if you say, I actually learned what the capital of Missouri was this morning. I thought it was Columbus. It's not, it's Jefferson City. Why do I need to know that? But for me, does that affect my everyday life? No. Most of the things that we learn in school do not affect your everyday life, even as you get older. I'm telling you that right now. Even though your job is a student, the information will carry over. Some of it will carry over and be important. Some of it I've never used besides the fact that I'm a math teacher. What's school doing? It's teaching you to think. It's teaching you how to attack a problem. Because in the real world, somebody's not going to be there holding your hand going, okay, so what do you think the next step is in this problem? You're going to have to go to Google, you're going to have to go on the internet, you're going to have to figure out how to solve the problem in your everyday life, whether it's your job, whether it's at home, wherever it happens to be. We are trying to teach you to think. With that being said, we are on day 5?
Yes.
With that being said, today starts the first day of real math for probably the next 3 years. You will use equations whether you think you are using equations or not. You may think that I do not work hard for my money. You may think that I come up here, I'm a cranky old man, I just come up here and I talk. What you don't see is the hours that I'm here before school, the hours during planning that I'm putting in the work, the hours after school that I'm spending grading or doing something for the school. I take my job very seriously. Therefore, I take my money very seriously. So when I go out to eat, you better believe that I'm looking at the receipt going, this plus this plus this doesn't match my total. That's an equation. When I go to the grocery store and I know something costs $3.99 and $2.70, yeah, you better believe that I'm adding it there. Because I truly believe I'm the smartest person ever. Like, it sounds funny, but if I think that I'm smarter than everybody else, that means they're dumb. Which means I don't trust them. So when I go to the grocery store and I'm watching them scan things, that computer can be wrong. I'm the smartest ever. Am I really? No, but you better believe that if they're jipping me $5, I'm going to be upset. So I need to know how to get my change back. I need to know how to pay a tax. I need to know how to give a tip. That's all equations. I checked my bank account this morning because something looked off. I've made some bigger purchases for the gym that we have at our house. And I'm looking at it and I'm like, man, I know I had, let's make it easy. I had $10,000 in my account this morning. I made $700 worth of purchases. Why is my account at $8,800? So then I had to start adding up some of these small things to figure out, was it right? No, one of my charges wasn't right. I had canceled it and for some reason it still went through. So I had to go and I had to make some phone calls this morning. But that's still solving an equation. Today is the first day of problems, truly, that you're going to use forever. Whether you think you're using equations or not. Now, scale drawings that we've done, yeah, I've used them because I was an estimator for my dad's business. But how often are you going to use an estimator? I don't know. How often do I walk through my house and be like, man, today's a good day to find the area of my floor. Let me measure my walls. No, I don't do that often. Okay? I use this a lot. So equations. Oh, also, why are these important? Oh yeah, well let's see. 8th grade, we spent a month and a half solving equations. My students are still struggling with equations because we didn't do them for a while, and then we're back into them. In algebra, if you do not know how to, let me try that again. If you do not know how to solve an equation in algebra, you will fail. Plain and simple. If you do not know how to solve equations, you will not pass algebra. If you do not know how to solve equations, you will not pass geometry, which you have to pass both of those. If you do not know how to solve equations, you will not pass algebra 2. So this lesson is going to carry over to next year, which is going to take the next 3 years of your life, just as an added bonus. So what is an equation? Addie, what do you think?
Like an equation without equals one?
Well, that would be an expression. Expression doesn't have an equal sign. So what is an equation? What do you think? So if an expression is something that doesn't have an equal sign, Braden?
Isn't it a mathematical sentence with an equal sign?
Yeah, it's a mathematical sentence with an equal sign. But we already know what else is a mathematical sentence.
Expression?
Yeah, an equation are expressions that are equal to each other. So I can have multiple expressions that must be equal to each other. But the key to it being an equation is what? Mr. Mahaney, what does an equation have to have? An equal sign. So you should probably write this down, right?
Yep.
Yeah. So it must have an equal sign. For it to be an equation, it must have an equal sign. Equations can be simple things because an expression has one of the three things: a variable, an operation, or a number. It can simply be x equals 7. This right here is an equation. Has an equal sign, has expressions. This is also an expression, or an equation. 3x minus 7 plus 4x minus 2 equals 7x minus 3 divided by 2x. Okay? That could also be an equation. Multiple expressions that equal each other. Okay? The key is they both have equal signs. They can be very basic. They can be complicated. Eventually you'll get to something like the second equation in Algebra 2 when you start solving quadratics, but not yet. So there is one other word that we need to know when dealing with equations. And the word is isolate. What do we think the word isolate means? Come on, I need more than one hand. Mr. Irvin.
To hold something together, like keep it from going.
To keep it from going anywhere, okay? So to keep it isolated, what do you mean? So to keep it from going anywhere?
Combine.
To combine it?
Separate.
To separate it from what? So to keep it by, like holding it over here, to separate it from everything else. Well, isolate in the bare basic terms, we'll call this the baby terms, means to get by itself. Okay? So Brian was saying, oh, I can isolate something by and he was like trying to show me like in a vase or something by itself over here. Braden was saying, hey, separate it. Yeah, get it by itself. If I isolate you, I usually send you down to the focus room. That's isolating you from the class. It's putting you by yourself, right? So isolate is to get by itself. Some of you I just like out of my class, not naming names, Ryan. Punk. So, there's a goal for equations. The goal of every equation. What do you think? And I'm telling you right now. I can't wait for your answers because you're wrong. What do you think the goal of the equation is going to be, Nevaeh?
To get the answer.
To get the answer. Did everybody hear Nevaeh? She said to get the answer. That's a great choice. No.
Not.
Well, Noah, go. To solve it. That's also It's also a great answer. No. Neither of them are wrong. Notice how I didn't say wrong, I'm just saying no. That's not what I want. The goal of every equation, because sometimes the goal of an equation isn't actually to find an answer or to solve it. The goal of every equation is to isolate the variable. But you didn't. Braden's like, that's what I was going to say. No, you weren't. You're the hand that always goes up, Braden. Don't be like, I was going to say that, but I just kept my hand down this one time. Liar. So the goal of every equation is to isolate the variable. Listen, isolating the variable means to get the variable by itself. So that means we only want one of the variable. Not 7x's, not negative 1x's, just 1x. That's it by itself. But how? That was my voice for that. You want to hear it again?
No.
Nope, too late. Don't like you guys that much. What? Really? You're going to talk trash to me while I'm holding this big old ruler? But how? So, there are rules that we have actually learned a little bit already of how we're going to get the variable isolated. And we get it isolated using inverse operations. You have heard these words before. I know for a fact that you've heard the word inverse before because there is an anchor chart with some properties right here talking about the additive inverse, where we add the numbers that are opposites and it gets 0. We've talked about the multiplicative inverse, where we multiply numbers and it becomes 1. So we have talked about inverses. But this says inverse operations. What operations do we know right now in math? We've got 4 of them. What operations do we know in math? Izzy, give me one.
Addition.
Addition. Somebody give me something else.
Subtraction.
Subtraction. Hunter, give me another one. Division. Give me one more. Avery. Multiplication. Okay. So the inverse operation. A better way to say this is the undo operations. So these operations undo the math. So what undoes addition? Subtraction. So the inverse operation of addition is subtraction. What is the inverse operation of subtraction? Nevaeh.
Addition.
Addition. Those undo things. Cole. I still love that name, man. You know why? Because it is my son's name. Oh, man. Cole, if my son's half as cool as you, he's going to be awesome. Cole, you're the man. Inverse of multiplication. Division. Mr. Golden, how are you? Good? Why are you smiling at me like that? Stop it. It's creepy, man. You alright? Your face is a little red. Kind of looks like Ryan's shirt. Do you have a fever? Should I be worried, Ryan? Are you sick? Don't come near me if you're sick. What's the inverse of division, Ryan? Multiplication. Questions so far? Okay, those are our inverse operations. Now, I hate to do this because I've never done it, but I'm going to need help. And somebody's going to be on a video. And since I only know several of your parents, I know Addie's parents, and I know her parents aren't going to be upset, so I need your help.
What?
Come on up.
Oh,
You're in the YouTube video.
She's so confused.
So Addie's going to be on the video. Stop. So, an equation. Addie's like, I don't want to get on this video. You're just going to be barely in it. Just wait. So, an equation is like a seesaw. Okay? It is balanced. Where do you think the balance point is in every equation? What's the middle, though? Anna? No?
The center.
Well, what's the center, though? What's the center of an equation? What? The equal sign. Okay? So right now, here is my equation. Wait, just step. I'll tell you when to stop. Come on. Stop there. Good. So Addie's not in it. You're going to have to reach your arm out. So, Addie's like, oh, good. I'm not. See, you can even look. You're not in it. So, watch what's going to happen. We're both going to put 4 fingers on this seesaw. Put 4 fingers on it. Okay? Just your arms there. Is it balanced still? Does everybody see that? Okay? It's level. It's good. Take away your 4 fingers. Okay. It was no longer balanced. Does everybody agree that?
Yes.
Okay. So let's use. Wait. Put your 4 fingers back up. So let's think about this. What would we have to do if she's going to take? Don't take them off yet because it's going to fly that way. If she takes off 4 fingers, what do I need to do to keep this balanced? We say it again. Take my 4 fingers off. 1, 2, 3, go. And it stayed balanced. So what I did on my side, she had to do on her side. Yes?
Yeah.
Put 1 finger on. Okay. We're going to multiply this 1 finger by 3. So what's 1 times? No. So how many fingers do we have on? We multiply 1 by 3. Don't change my balance. Ready? 1, 2, 3, go.
Oh, see.
3. Why do we have 3 fingers? Because 1 times 3 is 3. So if we multiplied my side by 3, her side had to have 3 as well. What if we divide it by 3? Ready? 1, 2, 3. So what happened? Wait. This is a perfect example. I love it. So I divided my side by 3 and I got 1. She took all of her fingers off. And what happened?
It flipped.
It flipped. Why? Because it was no longer balanced. It wasn't equal. So what we do to one side has to be done to the other side. Thank you for your help. Okay? That's the important part about equations. It has to stay balanced. Okay? So, let's jump in with some basic problems. And I'm going to start this off by saying these are problems that you can do in your head. Are you allowed to? Nope. These are one-step equations. You have seen them before. You've done these before. And listen, so have my 8th graders. I still started with one-step equations. They've got rules over here for all of their equations right here. It's from Unit 2. We did this a long time ago in 8th grade. But there are rules. As your equations get tougher, I'm going to want you to follow the rules. So even though you might not think that you need them yet, I want you to still get into the habit of using them now. Let's get into routine, okay? So, here's my first equation. X plus 14 equals negative 3. X plus 14 equals negative 3. Before we do anything else, as I see some of you counting on your fingers, doing things like this, that's fine. Our first rule is always going to be to find the balance point. And Emma told me, where is my balance point? I want you to get in the habit of putting a dashed line down the balance point. I promise you, eventually, probably not within the next week, But get into the habit of it now, that having a left side, having a right side is going to be important. Okay? So start the habit now so that when I say, okay, now we need that left side, you're like, okay, I've started with my balance point. I know where those sides are. So I have a balance point. The goal of every equation is to isolate the variable. So watch what I'm going to do. The only thing that I care about is the side with my variable. We have x plus 14. Do we want that plus 14 on the same side as that x? Do we want that? No, because we want the variable isolated, which means by itself. I just erased my 14. So what do we need to do to get rid of the positive 14? How do we move, or how do we isolate this x? What do you think, Nevaeh? We're not going to bring it down. So the goal of every equation is to isolate the variable. But how? Well, we use the inverse operations. What is the inverse of positive 14? Tegan? Now watch why this works. We subtract 14. This is the additive addition property, or additive inverse. 14, negative 14, what does that give me? 0. Do I need to write 0? Well, I could. X comes down, well, what's x plus 0? Just x. So we don't need to write the 0. 14 minus 14 is 0. The x comes down. You will have teachers, hopefully not in this district, but somebody will tell you, oh, they just cancel out. No, nothing ever just cancels out in math. They become 0. So now I have x, but we've got a problem. Think about my balance again. So I had 14 fingers on this side, and it was equal. All of a sudden, I took 14 fingers off, and it went like this. I'm scared of heights up here. This person's looking down screaming. How do we balance this back out? Noah?
Do it to the other side.
What do you mean do what to the other side?
The inverse.
So we take 14 from this side, which means we have to take 14 from this side. And you're still using your addition and subtraction rules. So negative and negative, they're the same. We add them, and we put the original sign back with it. X equals negative 17. This is showing your work. I'm going to expect you showing your work, whether you can do it in your head or not. Everybody with me? Okay. Let's do another one. So the goal of every equation is to isolate the variable. 3 plus x equals negative 1. And again, I trust that you can do this in your head. Some of you are like, nope. That's all right, good. I would rather you not be able to do it in your head, because then you're going to follow the rules. Weston, always. What's our first step for every equation?
We gotta find the middle.
Find the balance point. The balance point is that equation. Boom. That's where, just like on this ruler, that's where my finger is keeping this thing, wasn't balanced there. It's where it's keeping its balance. The ruler's off, I feel like, not my finger. Right? There's the balance point. That's our equal sign. This side has to equal this side. The goal is to isolate the x. What kind of 3 is this? Positive 3 plus x. How do I get rid of a positive 3? Come on, I need some hands. Braden.
The inverse operation.
Which is what?
Negative.
Yes, subtraction. It's a positive. We subtract. Why does this work? Well, watch. 3 minus 3 is 0. Do I need 0 plus x? No, I don't say, there's me. I don't say, look at how many 0 other me's are there, because I don't need a 0. There's x equals. But I took 3 fingers away from one side.
So you got negative 3.
Subtract 3 from the other side. Negative 1 minus 3 is negative 4. Questions here? Pretty easy, right? Let's try another one. 17 equals x minus 31. Does it matter that the x is on the other side? Oh, pay attention. Does it matter that the x is on the other side? Because we have another example there. Copying this down, right? Okay. It doesn't matter. It doesn't matter which side the x is on. Our steps stay the same. We found the balance point. Okay, Kylie. What do I need to do to get x isolated?
Inverse operation.
Which would be what?
Adding
Adding what?
31.
Very good. We have to add 31 to both sides. Why to both sides? To keep it balanced. Add 31 to this side, add 31 to this side. Negative 31 plus 31. That's the additive inverse property. It gives me 0. We didn't touch the x. X equals, bless you. We add 7 plus 1 is 8. 1 plus 3 is 4. X equals 48. Bless you. Could I check this? Sure, plug it in. 48 minus 31 is 17. Could I check this one? 3 plus negative 4 is negative 1. You can always check equations to make sure you have them. Let's try another one. Okay. Negative 7 plus x equals negative 14. Okay, Cole, what's my first step? It's always my first step.
So put a dash under the equal sign.
Yeah, to find that balance point. Put your dashed line. Split this problem into two parts. Okay, the goal is to get x isolated. So Izzy, what do I need to do? So we're trying to get x by itself, isolated, which means, go ahead. Well, what's the inverse? It says negative 7 plus x. What is the inverse of negative 7? So we're going to add 7. Again, why does this work? Because negative 7 plus 7 is 0. X comes down equals. Does it equal negative 14? What have I done wrong? Or what haven't I done yet? Izzy?
You haven't done the inverse operation for negative 14.
No. Not quite. We're not looking for the inverse of negative 14. Did I already change this balance on this side?
Yeah.
What did we do? We added 7 to this side. So what do I have to do to the other side to keep it balanced?
Add 7.
Add 7. The same operation happens on both sides. Negative 14 plus 7 is negative 7. Questions? I'm going to do one more. 27 plus x equals negative 63. So just like this problem, I'm going to tell you right now that I will see 50% of you on our first quiz, which will probably be like on Thursday for one-step equations. We'll miss this problem. And here's why. You will find the balance point. You'll look at this and say, oh, it's plus. Or you'll look at it and you'll try to add 27. Why does this not work? Tegan?
You need to do inverse operation.
Yeah, the inverse isn't adding because that would give me 54. Does that isolate the x? Well, no, that would give me 54 plus x. That doesn't help at all. So what's the inverse, Tegan? So we subtract. That's 0. X comes down. What do we have to do on this side, Kylie?
You would do something 27.
So we would what?
No, it would be 27 plus 6.
Not quite. So if we subtract 27 from this side, we have to subtract it from this side. Okay? What you do to one side, you do to the other. Everybody with me? They're both negative, so we can add 0, 1, 9. Keep the original sign. X equals 90. Now, I went a little bit farther in first hour, but that didn't give them a lot of time for the homework, and I want to make sure that you're showing me your first couple problems. So, when you get your worksheet, and it's already in the document for homework, but here's the numbers that you're doing for your homework. So I'll tell them once you get it, but we're doing 1 through 10, 23, 25, 26, 28, 29, and 30.